All right, here we go. We're graphing y equals a b to the x. So a is our coefficient, b is our base, with a power of x. But in this case, we're going to talk about what happens when y is between 0 and 1. It will never equal 0 and it will never equal 1, but it's somewhere between. As close as we can get to 0 to anything as close as we can get to 1 without going over. So if we have a function that looks like b here is 1/2, a is 1, and we have our exponent, which is x. The graph would look just like what we have on our screen. We're supposed to compare the graph of the parent function. Now, in order to do that, we'd have to pick some values, and let's pick -2. I picked -2 because I looked at -2, and eventually it'll intersect here. It looks like that's going to be at 4, so technically I have a coordinate -2, 4. So this point, something has to happen at that point if we change anything. Well, in this case, we're changing a to -1, but we're keeping b as 1/2, and we're keeping x as our exponent. That's all this means. Whereas our graph over here, our original, our a is equal to 1 and our b is 1/2. So hopefully you can see we only changed a from +1 to -1. All right, with all that said, we could go through and we could calculate this. This was -2. That would be the same as inverting or flipping the the base, the fraction, which means 2/1 squared, because the negative is what caused my variable to flip. Then that's the same thing as 2. So now I have -1 times 2 squared. That's what this little notation is here. Well, 2 squared is 4. So the opposite of 4 is -4. So what that means is at the same -2 I had in my parent function, I got +4. Well, in this case, just because we had a negative in front of our base, that means at that same -2, I'm at -4. Now, if we work it all through, what we'll find out is for every point we have on the parent function, it's reflected across the x-axis for the current function, or baby function, whatever you want to call it. Sorry, I just thought of baby function, and funny jokes came to mind. Now, with this, while my graph looks the same, and what I'm able to look at is basically whatever my domain was for my parent function, it's going to be the same domain for my current function. But our range is going to flip because our graph flipped. So if we look at our domain, I'm just going to say D for domain and range for our, I'm going to say all real numbers. Now, an R like this represents real numbers, so it's just shorthand. And that's what this is supposed to be doing. It's just really hard to write like that on this screen. Now, our range, I'm using capital R, is y is less than 0, because on the original, the range was y is greater than 0. Notice how both of them do not equal 0 in either case. But because all we did was flip across the x-axis, it's going to reverse the range. Now, if we flipped across the y-axis, then we would flip our domain. So domain and range are tied to x and y values. So you have to pay attention. Am I going across or over? What am I reflecting on? How am I translating? And things like that. In this case, we reflected over the x-axis, so our range is going to flip as well.